right, now we're going to talk about compounds, and as we go through, we'll kind of be comparing them to elements. Because remember, we said that pure substances can be broken down into either two groups, elements or compounds. You should have your elements on page 2. So now we're going to do our information about compounds here on page 3, or right across from elements. We said the elements were made of one type of atom. It was either one atom by itself or two atoms joined together, as long as they were the same kind, like with our oxygen example. With a compound, this is when we have more than one type of atom, so two or more types that are joined together, or in science we say that they are bonded together. Okay, that's what forms a compound. So we're going to say that they are made of more than one type of atom. We'll have some examples at the bottom that I think will help illustrate that as well. We said with elements, the properties were always the same, or they were consistent throughout. When elements combine to make a compound, the properties change. Okay, so for example, if we have water, which we might know as H2O, that's how we represent water. Hydrogen has its own properties. Oxygen has its own properties, but when they combine to make water with H2O, their properties are different. Okay, so they are not always the same as the elements that make up the compound. So we're going to say that the properties are different than the properties of their basic elements. Meaning whatever elements make up the atom, the properties are not necessarily going to be the same. Now when we say property, we're talking about a characteristic. Okay, some properties include state of matter, mass, volume, density, flammability. We'll spend more time talking about properties in stop number 2, but for now just know that we're talking about different characteristics of those substances. Compounds actually can be broken down into simpler substances. Okay, that's the opposite of elements. We said elements were as simple as it gets, but compounds, they can be broken down into a more simple substance. We said that we find elements on the periodic table. Okay, compounds are a combination of elements, therefore they're going to be represented by a combination of those chemical symbols. So it's going to be more than one together. So I'm going to write that here, that they are represented by a combination of chemical symbols and this is called a chemical formula. Okay, so when we have more than one symbol put together, that is called a chemical formula. An example of that, earlier I mentioned water, okay, so that's H2O. Whenever we have that 2 at the bottom, that's called a subscript, so that's just saying that there are 2 hydrogen atoms combined with 1 oxygen atom in this compound. Okay, so H itself is a symbol, O itself is a symbol, but when they combine, we call it a chemical formula. So this is the chemical formula that represents water. We're also going to add some examples at the bottom, like pictures, and then you'll draw more at the teacher station later this week. The first one that we'll draw is water. Okay, so we have water, which is represented, like we said before, by H2O. Okay, that's the chemical formula for water. So we have to have two hydrogen atoms somehow combined or bonded with one oxygen atom. So I'm going to draw one oxygen atom, and it is going to be combined with two hydrogen atoms. So these are going to be labeled with an H. And I'm going to stick with the same colors we used on the page before. Okay, so I'm going to color the O in blue, and I'm going to color the H with green. Using the color in our models really helps us see that we have two different types of atoms. We have hydrogen combined with oxygen, and that's what makes it a compound. That was the first thing that we wrote down, was that a compound is more than one type of atom. Okay. Another example is something called iron oxide. Iron oxide is like rust. You might know rust when, like if you leave something metal, like or your bike chain or a shovel or something like that outside, and it begins to rust or turn that kind of orangish brownish color. Okay, that's what we call iron oxide. The chemical formula is Fe2O3. Okay, so the numbers can get bigger. In this case, this is telling us that we have two iron atoms combined with three oxygen atoms. Okay, so I'm going to draw three oxygen atoms. 1, 2, 3. Okay, these are going to have the O for oxygen. And I'm going to draw two iron atoms. Those are going to be represented with the Fe. Okay, and then they're connected through what we call chemical bonds, which we just use these lines to represent. In 8th grade, we'll talk a lot more about the different bonds, but just know that when they're connected by the line, that means that they are chemically bonded together, and if there's more than one type, like in this case, we call that a compound. So again, I'm going to color the oxygen atoms blue, and then I'll go ahead and color the iron atoms red so that it matches what we did on page 2. You should have some space left over at the bottom. At the teacher station, you're going to draw more examples, so be sure that you're leaving that space blank.